capturing genomic data and storing it on a blockchain, or detecting fraudulent bank accounts and clustering them to identify patterns. That might just sound like a lot of buzzwords, but those are actually just some of the things that the two students on today's Tech Life Skills have actually built.
Hi, I'm Ananya and I go to Stanford.
Hi, I'm James, and I go to the University of British Columbia.
And we will be going live in 30 minutes on Tech Life Skills with Tanmay.
Yeah, make sure you join us live. We're looking forward to seeing you there.
Hello everyone, and welcome to the 33rd episode of Tech Life Skills with Tanmay. My name is Tanmay Bakshi, and every week I go live on Tech Life Skills, which, for me is a lot of fun, right? And it's fun because I get to hear from guests with a diverse range of backgrounds. And today's episode is no different. Today, we're doing a student special episode. Now, with every student special, I get to learn more about that unique perspective that students have when it comes to the world of tech, right? So all the way from why they decided to work with it and what exactly excites them so much about the world of technology, to, why they decided to work with it, what their experiences have been, and even their advice for other students that want to follow a similar path. And our guests today are two very bright students from Canada. We are being joined today by James Ross from the University of British Columbia and Ananya Chadha from Stanford. And here's the thing, instead of playing a game of telephone and actually having me sort of reiterate their introductions and losing some important and fun info, I think it would be really fun if you actually hear it from them directly. And so, without any further ado, let's welcome James and Ananya to the show. Hi James, hi Ananya, how are you?
Good, how are you?
Doing very well. Thank you for agreeing to be on the show. It's great to have you on.
Thank you for having me.
Of course, great to have you as well, Ananya.
Yeah, great to meet you too.
So, to start today, of course, as I mentioned, I would love to know a little bit more about the work that the two of you do, your experiences with the world of tech, what sort of led you to working with tech in the first place. So how about we start off with some brief introductions. James, do you want to start?
Sure. I am a second-year computer science student at the University of British Columbia. In my spare time, I'm working on a lot of data science projects. I am leading the software team of a team at UBC that's developing a smart bionic arm. I'm also the tech lead for a team that's working on a competition where robots are sort of competing and shooting each other. And then this past summer, I was working on some more financial crime related solutions. And yeah, I worked with these two about a year and a half ago at IBM, and happy to talk more.
Wonderful. It's great to hear. It's been some time since we've actually worked together on this sort of stuff, but it's great to see the sort of stuff you've been working on since then. Some fun stuff I can see for sure. Financial crime and machine learning. That's definitely an interesting area as well. So we'll be getting into that in a little bit. But Nanya, what about you? What have you been working on, and would you like to tell everyone a little bit about what you do?
Yeah, hello everyone. Tanmay, thanks for having me. I'm really glad to be here with all of you. So I started off doing gene editing research and ended up building a platform that lets people anonymously upload genetic data to researchers' data sets. The platform ended up getting moved into consensus, where I continued working on it. Then I got really interested in brain-computer interfaces, which is like this crazy field of building tech that allows your brain to connect to computers or machines. So I ended up building a brain-controlled remote control car, prosthetics, with sponsorship from Microsoft. Then I got interested in machine learning, so did a bit of that at IBM, where I met Tanmay and James, and then did machine learning with the Canadian military.
Wonderful. That's great to hear. A lot of really interesting technologies you're working with. And on the student specials, what's nice is that we get to hear from, all sorts of different students working on all sorts of different things. Some of them will be, just getting into the world of technology, right? We've had high school students on in the past. Some of them will have, already graduated university, just sort of got their first job when it comes to tech. And so it's really interesting to hear your perspectives. I know the two of you are still in university. I think what's really fun is that usually the age difference is pretty wild on the student specials, but this time the two of you are technically still teenagers, and so am I. And our good friend Michael calls this segment, the student specials, Teen Time with Tanmay. I guess that actually checks out this time. So it's definitely going to be a fun episode. So I feel like let's actually start out talking a little bit about you, James. So I want to know a little bit more about, what is it that drew you towards the world of technology in the first place, right? For me, I mean, it was, back when I was 5, me just sort of saying, I enjoy technology because it's the toy that's most interactive. and so, I sort of had that curiosity, and my dad saw that and was like, okay, so he just sort of introduced me to programming. But then for you, what was that sort of first moment when you realized that you were interested in technology and that it's something that excites you?
Yeah, I think that point for me was somewhere sort of in the beginning of high school. I was sort of introduced to it by, I think, my brother actually. And sort of, I think what drew me towards it was just the idea of solving all of these interesting problems that had some applications in the real world, right? So that includes things like robotics, where you have sort of a tangible feel of what you're contributing and what's happening, and more abstract things like data science projects, where you have this goal and you can work towards it in sort of new and interesting ways, and you can always create this interesting solution that has a real application. So I think that is sort of what drew me towards it, and that's what continues to keep me here. So yeah.
It's very nice to hear, right? I mean, I feel like everybody has different sort of points at which they're introduced to technology, and that sort of changes the way that you look at it, right? And I feel like everyone also has different motivation as to why they continue to work with tech. So it's interesting to hear that it's that sort of tangible element of technology, right? The impact that you have by solving problems that sort of interests you. What about you, Ananya? What got you into the world of tech?
Yeah, I think it was because when I was little, I would go to this summer camp at the Ontario Science Centre, and we would do things like put motors in sponges and then make sponges fly. And there was this one murder mystery challenge where there was like a thief, and you had to find out who the thief was. And the thief left you notes with like black Sharpies, and then you could like take the Sharpie and like decompose it into its like component colors. So you could see like the pink and the blue and the red and the green. And for each Sharpie, it was like a different like combination of colors. So then you can tell which marker wrote the notes, and then you could find the camp counselor with that marker, and then they were the thief. And then I think that they did such a good job of making science so fun. I believed that like science is magic and technology is magic, and it invokes so much wonder in me, and it continues to do that. So followed like what brought me excitement and joy, and then just continued learning more about tech for like the rest of my life.
That's very nice. I feel like what's really interesting is that with both of you and even with me, I feel like with a lot of people who are really interested in technology today, right? Your first sort of introduction to it usually is more from like that fun angle, right? Like it's usually something that at first is like, this is exciting, this is fun, and I want to figure out how I can do more with it, right? So like again, back when I was 5, it's not like I was like technology is the most interactive toy there is and I'm just going to use it. I was like, oh, I want to figure out how to do more with it, or I want to be able to build my own stuff with it, which is what sort of led to that level of curiosity. um, and I actually, that leads me to another question that is around education, right? So based off of the way that the two of you got into the world of tech, it wasn't through necessarily anything formal as part of like a curriculum, for example, at school that initially got you, sort of drawn into the world of technology. James, you mentioned your brother at first sort of had shown you a little bit of what you can do with tech, and how your story was pretty fun as well. But my question for you would be, do you think there should be some sort of, or not necessarily do you think there should be, how do you think we can improve the current sort of way that we introduce technology and programming to kids in, for example, high school, right? How can we make it more fun? How can we make it so it's something that actually matches them at that level? What do you think, based off of your experiences?
I think probably a good way to go about it would be to try and build some form of system that matches the organic curiosity that you get by learning about it in sort of a more in a sort of closer to the way that us three all encountered it for the first time. So something that sort of isn't necessarily too technical in a way that it would cause disinterest, but a way that is able to sort of spark that same curiosity that I'm sure we all felt early on in our tech journeys.
Okay, so it's all about being able to spark curiosity. Anya, what do you think?
I I agree with that. I think there are two ways that you can go about teaching something. One is like, this is a screwdriver and like this is a hammer. And the other is, let's make a car. Oh, we need a screwdriver. What is a screwdriver? Why do we need it? Oh, wow, now we need the screwdriver. And I think if you're learning like, for example, programming, like they teach that in high school. The equivalent of like, oh, this is a screwdriver, this is a hammer. It's like, oh, this is how you type in hello world into Python, or like this is how you do like 2 + 7, like this is an integer, this is a Boolean in Python. I think the equivalent would be, okay, let's start off by like, try to do something fun. Like, why might you use this? Why might you need this? And it's like, oh, we work backwards from there. And I think that begins from like a fundamental place of like curiosity and learning, and like starting with the why first. Like, it makes people excited because humans, we're not rational. We do whatever like we like whatever is fun. And I think you need to introduce people to like the reasoning for, and like make them excited before you can even begin to teach them technical knowledge.
Yeah, I totally agree with that. I mean, I feel like, a message that I've also tried to sort of get across through a lot of the tech life skills, even the student specials and a lot of my talks, is just generally that, even in school, I feel like one of the main goals that they should have, at least at a younger age, is not necessarily to get you into the nitty gritty of everything, but rather to sort of show you enough of every field so that you can determine what it is that you're passionate about. And I feel like that sort of experiential learning that you talked about, being able to work backwards from the problem instead of saying, all right, here are your tools and here's how you're going to use them. I feel like that's definitely a lot more effective. Which actually, I'm going to take a quick break from this topic because there is one more question that I have for you, James, related to what we're talking about. And it's actually from the live stream. So we're getting a question from Michael. He's saying, how did James get started in robotics, especially at a younger age? Robotics seems like a very daunting subject.
There are these small robotics kits you might have heard of. They're called Lego Mindstorms, and essentially what they are is they have these central blocks, and it's like the central controller is like this big block, and you can attach Lego pieces to it and little motors, and you can make it do pretty much whatever you want it to do. So I think I had one of those lying around somewhere, and that's sort of what sparked my interest in robotics. And then later, I had the opportunity at my high school to sort of get more acquainted with that at a more at a lower level. There was some actual there was an Arduino. We did some Arduino programming, and then we 3D printed some parts and got those together, and then we were able to build a robot. So it's sort of it's a natural progression from this small Lego robot to being able to build robots at a much larger scale to do more advanced things, which I think, yeah, that was sort of how I got introduced to it.
That's fascinating to hear. Lego Mindstorm is something that I've heard a lot about. I haven't actually used the kits myself, but I've seen different kids at different like organizations use them, and it's interesting, and it's something that I feel like actually on that topic. I want to ask you a quick question about the pedagogy of teaching technology, right? So I feel like I'm not sure if I'm even pronouncing his name right, but Joel Spolsky from Stack Overflow, at least ex CEO of Stack Overflow. In a blog post, he wrote once that the way we teach technology is, and I quote, a pedagogical disaster. Um, and I won't get into the nitty gritty of exactly what he said, but the way he described it just seemed so relevant to today to me, and I was like, this has to be a recent article. And then I look at the date, the timestamp when it was actually published, 2001, before the three of us were born. so, he's been saying that for a long time now, and I don't think much has changed, right? So I feel like, for example, what he said in that article, one of his key points was that there are these issues or algorithms. Technically, there are these algorithms called Schlemiel the Painter algorithms, and they're algorithms that scale really ineffectively, but because at a low enough size you don't notice them because computers are so fast, you end up shipping them in production applications. So for example, Excel, right, as you get a column that's too long, suddenly Excel's going to crash because every time it's doing an str length operation internally, it actually needs to go through the whole string and find a null terminator, which if it's too long, it's never going to find that null terminator. And so you're just going to end up crashing the application. And these are issues that can be avoided, and this is what Joel argues, that if we teach technology the right way from the ground up, sort of teaching people enough at the low level so that they know whatever they're doing, even in high level languages, sort of understanding the impact that has on a low level for a better user experience at the end of the day. But then at the same time, right, we're sort of talking here about introducing technology at, for example, a high school level where it really doesn't make sense, at least I think, to go to that nitty gritty and show everybody, here's how everything works, down at the CPU level. So my question for you, and maybe Ananya, you want to start off with this one, how do you think we could find a good balance for teaching technology that way, in the sense that, sure, in school, maybe the primary objective is to see what it is that you're interested in and see if technology is something you want to go down further in the future, but also how can we teach it in the right way, in the sense that they understand what's happening, but at the same time they're not bogged down by just all this technical detail whenever they're trying to build something.
I don't think that everyone should learn the same thing.
Yes.
I think that different people care about different things. Different people like certain things more. And so I think a more ideal education system would be one where students can follow their like natural curiosities and learn more about what they care about. I think it makes a lot of sense to teach kids about like the low level things, but at the start, like I definitely think it's iffy, because the first part of is getting someone excited and it's letting them connect authentically with whatever the subject is, so that they can like learn more from there. And then if they're excited, then they can dive deeper into learning the fundamentals. So I think that you expose kids, and I think that like education needs to be more personalized. Wouldn't it be cool if, like, let's say a first grader decided that they just really had a lot of fun with like tech, so then they went to like an 8th grade level and maybe they didn't go as far in other things, because maybe not a first grader, you need some fundamentals, but maybe like a 4th grader, because I definitely don't think that education should be the same for everyone. I definitely think it should be personalized.
Agreed. Yeah, everyone's different. James, what do you think?
Yeah, I think as we were talking about earlier, the sort of first goal of the education system when introducing students to tech should be to spark curiosity. It should be to maybe present them with not necessarily the tools, but maybe a challenge that interests them, and they have a clear end goal, and they can determine their own path to achieving that end goal, and you can supply them with the tools they need to do that. And maybe determining how to do things like prevent those issues of non-scalable algorithms could come at maybe a later date, or if you want to do it earlier, you could present them with a problem where they would encounter an issue like that naturally. Like you could encounter them, you could give them some problem domain that you need to create a solution that is scalable.
Mm-hmm.
And maybe they'll develop their own solution first. It's a little bit naive, and there are problems with scalability with that. And you can sort of guide them in the right direction to producing a scalable solution. And then you could and then you could go from there, teaching them how to build scalable solutions. Although I really do think that is probably something that should come at a later date, especially since students who are in high school might not necessarily going directly into industry where they need to develop this kind of solution until much later on down in the technology, the path of learning. So I think if you're going to teach students about that early, then probably present them with a problem and interesting challenge that sort of requires them to create the scalable solution naturally.
Mm-hmm. Yeah, so I really like the sort of viewpoint that both of you have here. I mean, first of all, I really agree with, Ananya's point of education needs to be personalized, right? Because everyone's different, everyone's going to learn differently, fundamentally. We all learn differently, right? And I for example, as a developer, I happen to learn new frameworks and APIs by just completely ignoring the documentation and just kind of jumping right in there, as you probably know, as I did with LLVM, just kind of jump in there and figure it out over time. But then, there's some developers that'll be like, it's really important for us to, read the documentation and, understand it, maybe buy a book on it or something of that sort. Everyone's going to learn differently, and I feel like especially at a young age, right, it's important for you to be taught the right way. And of course, what you mentioned, James, around, which I think is actually pretty great, being able to work backwards from problems that require you to, sort of implicitly figure out these sorts of algorithms and scalability issues. I feel like that's also interesting because you're still working towards a nice problem, right? A problem that sparks excitement, and learning those concepts along the way is a great way to go. Now, we do have a question from Shiva from the live stream that I want to quickly ask. There are actually two, and I want to start off with one of them. And she starts off by asking, what is a common pattern you've seen among all sorts of different technologies? So that's pretty open-ended, but if either of you would like to take that first, go right ahead.
A common pattern seen across all technologies. I think probably since technology as a field is so broad, the most generalized statement I can think of to make about all technologies would be that they're trying to innovate in some way, right? Mm-hmm. If you have this, you have your desired problem, and then you develop a technology that is the solution to that problem. So if my problem would be people or amputees don't have enough recourse, they don't have enough resources readily available for them to be able to lead a normal life after their amputation. The solution would be something like developing cheap, smart prosthetics, or maybe to solve paralysis or paralysis-related problems, you could do something like building a computer interface, and you could do various things with that. Or if we're going to a completely different field, technology is still applicable to things like building Excel to work with data more easily. So it's such a broad field that that's sort of, I think, that's the one generalization you can make. You have these problems, and so you build technology to solve this problem in some way that's applicable to society as a whole.
Mm-hmm.
I definitely agree. I think, like, by definition, technology just helps you solve problems better. And then when I think about, like, where does new technology and innovations, like, come from, I think there's, like, a few different categories that come to mind. So, like, first is, like, incremental innovation, like you make something a little bit better. Like maybe you, like, improve some certain metric, or you can like take the next step. I think another one is, like, getting something totally different. And so, like, how can you go down the path of, like, totally different innovation in, like, new tech to solve problems? And I think one aspect is, like, inspired from nature. Like, you see this all the time, like biomimetics. We don't understand nature around us. Like, biology is the field of, like, trying to understand what is going on. And so you can see, like, gene editing came out of, like, researching a bacteria's immune system. And there's so many, like, different like aerodynamic principles that come from, like, flight in nature. So you can, like, look to the world around you, Or I think the other option is like you can come up with new ideas yourself. So maybe that's like merging a lot of different ideas that exist in the world and like bringing them together. Or maybe it's like you just had some sort of like out of body experience and just mapped some neural connections and thought of something new.
Okay,
I think
sorry, go ahead.
no, go ahead.
No, I was just gonna say I love the example that you brought up from biotech because it's kind of a waste, especially as a technologist. It kind of pains me to see how we have like 4 billion years of evolution that we just kind of aren't really leveraging to its fullest potential. So it's like it's kind of like we're reinventing the wheel a lot of the time, and when we reinvent the wheel, the wheel that we invent isn't nearly as good as the wheel that's already there. So
Yeah,
it's nice to see how we're using technology to be able to derive inspiration from the biological world.
I totally agree. Like if you take like a MacBook and then you take like an iPhone and then you take like an AirPod and then you take like a plant. And like I ask you of these four, which are like the most technologically advanced, like I would argue that it would wholeheartedly be the plant.
Absolutely.
Um, and so like we don't even understand entirely what is going on in that
Yeah.
plant.
Totally agreed. It's amazing that they are that complex, and I feel like because we don't understand it all is one of the reasons why we sort of gloss over its complexity and we almost just take it for granted. Because yes, of course, there's a plant there, right? That's sort of natural to us, but then technology things like a MacBook, for example, these are things that are kind of odd to us. They're things we didn't just evolve with and just don't happen to be there. They're things that we create, so we inherently start to see a bit more of the complexity behind it. But it's definitely really interesting to see how we can derive inspiration from there and apply that to solve problems. So there is another question from Shiva, and before I ask that, I do want to ask a sort of a prelude question first. So I'm going to ask this for both of you. What are some of the most fun experiences you've had with technology? So some of the most fun things you've built or done or used technology for, anything fun that relates to technology. What would you say? Two of you can, whoever wants to take that one first.
Hmm. I think probably the most fun experience I've had to date is probably it was midway through last year. We were gearing up to compete in Cybathlon, a bionics competition. So we had built our bionic arm, and we had our pilot who was going to wear it. And I think just seeing the results of all of our work and having just sort of the fruits of our labor, and having this person actually put on the thing that we had built and use it, and do things that they wouldn't be able to do without this piece of technology that we developed, I think is just such a satisfying feeling, right? That's sort of the whole reason why like gone into tech in the first place, because you have all these problems, you want to develop solutions that you feel have some kind of impact, and seeing that impact in action, I think is probably one of the most satisfying things that you can get out of tech. So I think that's probably my most fun sort of thing that's happened to me in tech.
Very nice. Being able to actually see the impact that your technology has, I totally agree, is just a different experience altogether, right? Building it, that's definitely fun. Testing it yourself is really fun, but then actually seeing people use it and be like, it's actually been useful for them, or changed their life in some way. I feel like that's just on a whole other level. But what about you, Nanya? What's some fun stuff you've done with tech?
When I finished building my brain controlled remote control car, when um, we built like these robots that could paint paintings. Um, I totally agree. Like every time I finish building something and then I see it doing what it was supposed to do in the world, it's like, oh, that's crazy. And it is crazy.
Okay, so there's something you kind of just glossed over there that we're gonna have to rewind and talk a little bit more about. What was that robot that you were talking about that actually paints paintings?
Yeah, so this was for our grade 7 art class. And our teacher was like, let's do this project. And so she gave everyone motors, and they were totally like abstract paintings, by the way. But you could like make the robots go in like circles, or like um, make the markers do weird patterns, and then it would create this unapologetically creative masterpiece.
Yeah, it's yeah. I feel like labeling it as abstract art would definitely be pretty important. But no, but seriously though, it's great that that's something we worked on now. Just so I understand a little bit more.
You could totally do a non-abstract art painting as well, though.
Yeah.
I don't even imagine it would be complicated.
Yeah.
If you wanted it to be like you could use like machine learning to generate an image that didn't exist before,
For sure.
and then you could just,
Yeah, no, for sure. The technology's there. Maybe a couple iterations down the line, these bots will turn into a printer.
Printers are insane. I was reading about how printers work the other day. Like, they're crazy.
I mean, yeah, they're pretty technologically advanced. Unfortunately, they break pretty soon. But I mean, I guess what can we do about that?
Might
Anyway,
be intentional.
yeah, that's the business end of technology. We're not here to discuss that today. But regardless, there is another question from Tassin that I want to ask here. And he's asking a little bit more on the education end. It's a little bit more sort of generic from tech. He's asking, would it be good advice for someone that's homeschooled to learn something that they're most passionate about? So he didn't mention what it is that he's passionate about. It could be technology, it could be anything. Do you think it's good advice for someone that's homeschooled to learn what it is that they're most passionate about?
So this is my thought with passion, right? I don't think you just wake up one day and you're like, I'm passionate about programming. Like, I don't think you just like have an epiphany that this is what you're passionate about. Or you wake up one day and you're like, you know what, I want to do like music for the rest of my life. Like, I think you develop your passion over time. It's the same way. You don't just wake up and you be like, oh, this person is my best friend. Like, you develop your best friend over time. You develop your passion over time. And so you like start something and then you learn a little more about it and you're like, hey, like this sticks with me. And then you do it a little bit more and you're like, hey, I really enjoy this. And you do this a little bit more and you're like, oh, whoa. And then you just keep going. And then eventually you develop like a long-term, happy, passionate relationship with this subject. And I think that that it's important to do things that you enjoy because it allows you to become so much better at it. It allows you to like find joy when you do it as well. But I would also like caution, like no one should feel like they need to know what they're passionate about. You try things out. You try out a bunch of things and then you like go down the path and then you see what works in action. Like you can't decide these things in theory, like pre-recorded. So I think if you have something that you enjoy, like by all means, please, like it would be stellar if you could like, if you love like devoting yourself to it, like that's amazing. But then also like to develop your passion in the first place, like definitely explore a bunch of options and then see what sticks.
Yeah,
Totally
absolutely. I think sort of your schooling, especially from schooling, it's a journey of self-discovery, right? Like you want to be able to determine what you're passionate about and then maybe take your studies further after that. So if you have something you think you're passionate about while you're being homeschooled, absolutely, you should definitely take a look at it and maybe study it further. And if it turns out to be something you're very passionate about, maybe that could be your driver. That could be what you do later on in life. And that's absolutely the reason that I would study something further while I was homeschooled if I was passionate about something in that period of my life.
I totally agree, right? It's all about when you're doing something that you're passionate about, the joy that you derive from actually doing it enables you to be really good at it because you end up spending a lot of time at it, first of all. But also from there, I also agree with your sort of point there, Ananya, is that you never just sort of wake up one day and be like, yeah, I'm passionate about something, right? It's all about being able to develop the passion, which is why I also sort of like what you mentioned before in the sense that, schools and generally education institutions, what their responsibility is at least, at a younger age, not just trying to, teach you things, but also trying to give you enough of exposure to different things and give you enough experience so you can figure out, generally over time, what sort of subjects or areas you gravitate most towards. And it can be multiple subjects too, I feel like. It's not just that, people need to be passionate about one thing, right? I mean, I happen to be really passionate about technology, but I'm also really passionate about like language understanding and linguistics and these sorts of things, right? So it can be, and then what's really interesting is you can find the intersection there, right? So like, for example, today I have a talk right after this one actually on natural language understanding and why deep learning models fail to do it. So you can find those intersections really nicely. So I feel like when you're passionate about things, it does work out. So yeah, if you know that you're passionate about something, it's usually good to pursue what it is that you enjoy. Now, there actually is another question from Tassin again. And he's asking, what's the first or most basic class or course for a high school student that you would suggest for someone that wants to explore the world of technology for considering a career in that? Before I hand it over to the two of you, I would recommend my book. My resources. Tanmay teaches Julia, especially for kids of all ages, and really just anyone that wants to get into the world of technology is a pretty good resource to get into tech, and specifically with machine learning. And actually, one thing that I will say really quickly, I'm going to take your analogy here, Ananya, for a second. But the analogy that you had around, being able to show people that not necessarily that here's a screwdriver and here's a hammer, let's use them to build a car, but rather, we need to build a car and sort of work backwards from there to figure out what we need. I will say that is something that I generally try to incorporate into my educational material as much as possible, including these books and the YouTube channel and stuff like that. But that's just what I have to say. What did the two of you say? What are the most basic courses or classes that high school students should take to explore the world of technology, to consider a career in it?
First, technology is like the vaguest word I've ever heard in my whole life.
Yeah.
Like, we defined it earlier as like something to help solve a problem. Like programming is technology, sure, but there's like a bunch of other things that are technology as well. Like technology is literally in every industry. Like, I would be surprised if you managed to go into a job in the future that didn't have technology.
I mean, I don't think there are many jobs that don't. I don't think there are any jobs that aren't in some way using technology.
Yeah, but if we're talking about programming, I can offer resources to be helpful. I think something that's really important is like the act of like learning how to learn. And I think that when you learn that, then you can master almost anything. So even like learning how to find like the best resources for whatever area of technology you're excited about. And if you're excited about like machine learning, that'll be different than the resources. And if you're excited about like robotics, that'll be different than like biotech or gene editing or nanotech or space or quantum computing or blockchain or nuclear fusion. So I think like you should explore like these like ideas of like different technologies, brain computer interfaces, virtual reality, augmented reality. Like, there's a ton of really good resources on YouTube of like exposure channels. Like, there's one called Seeker, Discovery News, like where you can like expose yourself first. There's also like a website called Futurism, another website called Verge. So like a bunch of like tech news, tech videos, science videos where you can like expose yourself and find what makes you excited. Then from there, I would recommend like Coursera and edX. Like, when you find something you're slightly into, and you can take a bunch of like college courses for free, and like the intro courses especially. And books are stellar as well. You can find out good books. Usually like people create repositories of like good books for each subject. And then you can go from there. For programming, like a classic edX course like CS51, everyone takes that one. And then you go from there.
I totally agree with you there, but before you go, James, I'm going to also say Coursera and edX are great, but don't forget cognitive class. So, yeah, no, cognitive class at AI is also a great way to get into technology. And I do agree, technology is super, super vague. So a lot of these resources that I'm talking about, including, my books or what you mentioned, Coursera, edX, I feel like Coursera and edX are more general than just programming, of course. But, quite a few of these resources, when we say technology, we mean programming. But then again, actually, to sort of extend, sorry, before I hand it over to you, James, is that because technology is so vague, I feel like it can almost be unclear for a lot of people what their passion really is, because I feel like for me, for example, my interest is like raw technology, right? So I do care about where I apply it, right? I try to apply it where it actually makes an impact on people's lives. But at the same time, generally, I care a lot more about or not necessarily care, but what excites me is the technological, advancement behind a certain application. But then there would definitely be other people that would be like, for example, I'm very passionate about specifically healthcare or specifically finance. And due to that passion that they have, and due to the fact that they want to innovate, technology is something that they sort of need to learn on their way of applying it in a certain field. So I feel like that's also something that would be interesting. Maybe that's helpful for you, Tassin, but go ahead, James.
Yeah, I think that's absolutely a good point that Ananya was bringing up. But I think, to me, the most important thing about learning something new like technology or programming, is that you want to make sure you have that passion first. You want to make sure that to keep yourself interested and keep yourself motivated to learn these new things, you want to have something driving you to learn these new things. And I think a good way to do that is to choose some form of problem. You want to have your problem domain, and then you want to learn the technologies you need to solve that problem. So it could be something like, I want to build a series of IoT devices that control things inside of my home, something to close my blinds, or something even more advanced, something to make me coffee in the morning, something like that, right? So you choose your problem, and you're like, okay, what do I need to be able to achieve this goal? And for something to close my blinds and open them in the morning, could be to like, you want to learn how to operate a Raspberry Pi, build a Python script to move motors or something like that. And so something you could do is I could say, okay, I don't know Python, so I'm going to go to some online resource. There are definitely tons and tons of online resources of learning Python. I think Automate the Boring Stuff is a pretty popular choice for that. And you could learn Python there. And then using that newfound knowledge, you could get a Raspberry Pi and you could say, okay, how do I control this? And then you look up some resources on how to operate a Raspberry Pi, how to use the GPIO pins to operate a motor, and then you operate a motor, and boom, you've done your first project, and you've been motivated throughout this entire process to achieve your goal, right? So you've got a little glimpse of the whole process of formulating your problem, formulating a solution, and incrementally developing your solution to achieve this goal. And then you have that immense satisfaction of actually having something that does something. And so for me, learning anything related to technology was just a series of those steps, right? Like I had many projects over the past few years that I've wanted to complete, and I've had the motivation to complete. So I learned the things I needed to learn in order to achieve those goals. And that's sort of what's kept me motivated to learn new things. And you can, as you improve, you'll need fewer and fewer resources. Or if you're choosing more advanced projects, you'll need more advanced resources. And then you have this sort of natural progression of learning. And obviously courses are a great way to sort of augment that. Maybe you don't know exactly what area of problems you want to look into. And then you can take like cognitive class courses to understand new areas of work that you could go into. And then that could eventually lead to a career in tech or something like that. So I think that's probably the progression that I would do with.
Mm-hmm. Yeah, no, I first of all love what you mentioned around, being able to have that natural progression around, technology isn't just about programming, right? I feel like that's one of the things that a lot of people see is, right, when you start to learn to code, you see that immediate end of, here's the exact problem you need to solve, now solve it, right? And in the real world, that's not necessarily your goal. You have a pretty open-ended problem, and you're sort of trying to figure out exactly, where you're trying to reach. As you reach there, things change. And so being able to get an experience for the whole sort of pipeline, as you mentioned, understanding what the problem is, understanding how, you want to go about solving it, and sort of that sort of process of iteration, I feel like that's also really important. So a few of these resources that we talk about, things like Coursera, edX, Cognitive Class, my books, whatever, we will link them in the description, so you can take a look at that.
We should tell them why we're smiling whenever someone says cognitive class.
Well, I mean, it's no, it's we've James and I have had some experience with the back end of that system, but no, I know I've personally built a couple of the courses on the platform, and James has worked on the back end a little bit, and we know the people that are working on those courses, and we can sort of vouch for the content being high quality. So that's one of the reasons that I enjoy it that much.
These two made it. That means it's super stellar.
In part. there's a huge team, but yeah, it's a great platform. So now I do want to sort of get back. I sort of went on a tangent there because of a couple of questions, but back to Shiva's question, right? I had asked you some of the fun experiences you've had with technology, but I have to get back to Shiva's question now, and she's asking, what are the challenges you faced working with technology? Now, specifically, she said working with technology that's rigid, but I'm just going to go ahead and, simplify that down, make it a bit more generic, and I'm going to ask you, what are some of the challenges you faced working with technology? So I feel like maybe there's two different questions here, right? So I personally, what I want to know is, of course, what are some of the challenges you face using technology, but also what are some of the most challenging things you've done using technology? So let's go ahead and answer both. Maybe either one of you can start. I'm fine.
I think the most challenging thing, or the most challenging experience I've had with technology, I think comes down to when you're working on. I think maybe I'm not sure if this is sort of what you had in mind with this question, but the most challenging experience I think when dealing with technology is if you're working on a team that maybe you have this goal in mind, except you're having trouble communicating sort of the ideas you're working on. And so I think that's sort of a common experience, or a more common experience in team teams. It's harder to communicate with your team and get everyone sort of on the same track working towards a common goal. So I think the most challenging experience I've had with technology is when I have a clear vision of what I want this project to look like, but I think other people, like everyone else on the team, maybe has different ideas. So we have to develop a compromise, and we have to work towards this maybe new solution that isn't what people envisioned, and so there are tons and tons of struggles along the way of adapting your solution and overcoming these problems. And I think that's a pretty challenging aspect of technology, or it can be. In terms of the most challenging thing of technology that I've worked on in the past, I think I don't think I consider challenging projects to be a bad thing. I think the challenge is one of the most interesting aspects of technology, but I think probably the most challenging thing I've worked on in the past was probably this past summer, when I was working on developing a solution to combat financial crime for RBC. It was a really challenging problem to address, because there are so many sort of facets to the problem. You have to figure out how to address all of them and develop a solution that's robust enough to combat financial crime in a good way. So I think that's probably the most challenging project I've ever had. And the most challenging aspect of technology to me is sort of adapting your solution to fit the team's needs. I think that's always a challenging aspect of developing any good solution.
Mm-hmm. Yeah, I mean, I feel like definitely challenges aren't a bad thing, right? The challenges are, if
Absolutely.
anything, they're a good thing, right? Like, you can attest to this, that the some of the projects that I've worked on have been huge challenges where we're not even sure if what we're doing is technologically possible, right? All the way from the example of being able to trace trillions of function calls in a very limited amount of time and space, and things like this that we worked on. We weren't even sure if it was physically possible for CPU to do that, but we did it, and it ended up working. So
Woohoo!
it's yep. So challenges are a good thing for sure. I agree. But Ananya, what about you? What are some of the challenges you face working with tech, and what is the most challenging thing you've done with tech?
Yeah, I would. So for me, it's always like I think about what I want to build first, and like I see it in my mind, and then I wonder how to go about it. So, like for example, once I was like, I want to make a talking robot, and then I was like, great. And then there was another time I was like I want to make this like genetic data on the blockchain thing, or I want to make a crypto, or I want to make a like brain controlled item. And then whenever that happens, I'm always like, oh no, how do we do this? And then that's always like the biggest challenge. Like once you have the idea, like developing the plan and then being able to like um, execute it, and then having like something being thrown in your way, like five challenges that you never would have expected. And then you're like, oh, like the whole process I think is a giant challenge, but it's very fun
Mm-hmm.
in the end.
Yeah, it's everything can be a challenge, and especially actually I'm gonna sort of for a moment touch upon one of the things that James said before I get back to you, which was one of the challenges within tech really isn't even just the technology; it's working with people, and especially within a single team. Yeah, that definitely is a challenge. But if I might actually add to that, I feel like a greater challenge than working within a team is working across teams, because oh god, I have unfortunately too much experience with projects that have hundreds of teams and each team just not wanting to coordinate with the others. And that just ends up being terrible because every team has their own individual goals or milestones that they want to reach, but they need the help of the other teams to do so. And, actually getting that help and getting them to sort of sync up that way can be incredibly difficult. So, I feel like it also kind of relates to cybersecurity in a way, because even within like cybersecurity, the actual vulnerabilities are very rarely of the technology itself. The vulnerabilities are in the people using the technology, right? If you click on a link in an email that you're not supposed to click, that's not the technology's fault, right?
Yeah.
You're the one that clicked the link. So,
Absolutely.
so it's people.
I want to like double tap on that because I think that's so key. Like learning technical things is so important, but I think what's like arguably more important is like learning how to deal with people, because like people manage these technologies, and like these soft skills I think is what enables like a piece of technology to become super powerful or super impactful. And sometimes it can even be harder to learn because there's no set like this input makes this output. But
Yeah.
I think it's like definitely something that we should all try and be better at.
So maybe that's why developers prefer working with computers over people, is because there's always deterministic output.
Yeah. I really like the cybersecurity example you gave. You could build the best system, like the most secure system in the world, but I think there's an anecdote about someone dropping a CD in a parking lot that's that had malware on it. Like a sysadmin dropped a CD with malware on it inside of the parking lot outside of some corporate office to see if anyone would put it in the machine. Yeah, and a very high up executive ended up putting it inside of their machine and ended up like breaching the entire, or they would have like breached the entirety of the corporation's security if it wasn't actually a sysadmin that did that. But yeah, it's that to me is a really interesting anecdote, because it doesn't matter, or it does matter, but it like often you can build the most secure system, but if you have one tiny flaw, then that can be exploited by people.
Yeah, and we're starting to see technology that's a little bit more people-proof, I guess, right? With like the secure enclave on the iPhones, and now the transition to the same thing on Macs now as well. We're starting to see Apple say, or lots of companies, but specifically Apple, and actually Microsoft now with their new Pluton chip, which was announced, I think, like this morning or maybe yesterday, where they're trying to say, all right, we're still going to let you do things because we're not going to lock down your computer, but we're going to make it really difficult for you to end up messing something up really badly. Now, if you still click a link in an email that you're not supposed to click on a Mac, you're still going to get infected. But, maybe if you leave your Mac out and someone steals it, they wouldn't be able to reset all your data, right? So we're trying to make it more people-proof, but it's definitely hard. All right. Now I want to answer a question. This is something that I think is really fun. Not necessarily fun, but for me it's fun. From Akash on the live stream, he's asking, many students criticize computer science education institutions for being more focused on like the data structures and algorithms and competitive programming, and consider these subjects impractical. What are your thoughts? Really quickly before I hand it off to the two of you, one of the things that I really don't like about the way that we teach people how to program and also interview programmers for job positions, for example, something that I really, really hate, and especially when it comes to, competitive programming, things like LeetCode or whatever, the things that I really hate about this is that they're not teaching you how to program, right? They're not teaching you how to work with technology. They're teaching you to take a very, very specific problem definition, and they're teaching you to happen to write some code that ends up solving that very specific problem. That doesn't translate to being a good software developer at all necessarily. And maybe a good analogy would be, just because you're an amazing Olympic swimmer doesn't mean you'd be a great officer in the Navy, all right? Like it doesn't translate. Just because you can solve every single challenge on a certain competitive programming site better than everybody else doesn't mean you're going to be the greatest software developer at a certain company. But as is the problem with a lot of different things, the disconnect between the actual, engineers and the people at different companies, and for example, HR can be pretty immense. Like there was this one job posting asking for like what I think it was 8 years of experience in Swift when it was just released like 3 years ago.
Yeah.
So, but regardless, what are your thoughts? Because that's just my sort of first take on it. But what do you think?
Yeah, I think that's a really good take. I think that's a huge problem with interviewing. I think inside of academic institutions, I don't think I have as much of a do with interviews, and the reasoning behind that is because they're not necessarily teaching you how to program in an applied sense. Which sure you might take issue with that, but I think instead of doing that, they're sort of trying to teach you how to think and how to develop solutions to new problems. And I think the idea is that all of this applied experience will come outside of your actual class time. So you'll take these new ways of thinking about problems and developing solutions for these problems, and you'll apply it to your own life, and you'll create things yourself, and that will be your applied experience. Or you'll do things like co-op semesters in university, which will be work terms, which is where you'll also gather that applied experience that you need. In terms of interviews, I absolutely do think that's not the best it could be. I think if you're interviewing someone for a position, you're past that educational point. You're not trying to teach them new ways to think or testing their ways of thinking. You want to test their ability to solve problems specifically inside of your domain of work. So if you are an organization at IBM that's doing web development, you don't want to quiz people on algorithm questions that they're never going to use, especially if they're like a front end developer that's building some interface, right? Because you don't necessarily need to be able to invert a binary tree on a board. Like you need to be able to develop powerful solutions to whatever you're working on. Which it's absolutely true. I think your analogy of Olympic swimmers and officers in the Navy, because it's not what these people are working on. If you're applying for a job, you want to be tested on what you're going to be working on. So I think doing all these algorithmic coding questions on interviews is not necessarily what should always be done. But yeah, in education, I think it can be a useful tool.
Yeah, and also before I hand that over to you, Nanya, because I think I do want your opinion on it as well. Akash did ask a follow-up question, but there should be some sort of reason that all the large companies, FANG companies, always consider them or consider competitive programming as a primary criteria for selection. I totally agree with the next comment on the YouTube live stream saying it's a lazy approach that's used when you're a very large company. Totally agreed. The fact that they use it doesn't mean that it's a good thing to use it. It means that they're not doing it the right way. So regardless of who's using it, it's got to change. Just because Apple made, the iPhone 6 that bends in your pocket doesn't mean phones are supposed to bend. So it's got to change is what I'm saying. But regardless, Ananya, I want your opinion on it as well.
Personally, for all of my programming jobs, I've never done a programming interview. And I'm taking my first CS class next quarter. So I don't know if this is in my circle of competence to be able to answer this question.
That's fine. No, I totally understand. From the
oh,
code
but I
that
do
you
want to. No, but I do want to I do want to mention, like, sometimes people think it's like impossible to think of something better than a like cut and paste like programming abstraction data structure interview. But I definitely think that there are like, it will require creativity, but there will definitely be better solutions that exist in the future.
Mm-hmm. We're going to need better solutions, right? We can't just make do with hiring people based off of the wrong criteria. And I feel like it kind of boils down to the fact that when you're testing against the wrong criteria, the right objective, the things that people do are going to be wrong as well, right? And I mean, this is an example that I'm going to be talking about more in my other talk today. But right, when you're measuring against the wrong objective, you're going to end up doing the wrong thing, right? So one of my favorite examples, and this is something I bring up quite a few times, is an article by my mentor Timothy Duncan. He has this article, A Tale of Two Police Departments, and it's a really great article, and he talks about how in the U.S. Police departments were incentivized to just make as many arrests as possible, thanks to the certain policies or grants put in place for the war on drugs. And that led to the situation that we have today. So when you have an objective, no matter what your idea is behind putting that objective, people or even machine learning algorithms, whatever, they're going to find the laziest way to achieve that objective. And if that just means arresting as many people as possible regardless of reason, well, that's what's going to happen, because that's the objective you're measuring against. And so similarly, in interviews, if we're measuring against this sort of competitive programming standard, I feel like we almost train people to do the wrong thing in a way, I guess. But that's something we'll get more into later. But regardless, though, Ananya, now I want to talk about something that is within your circle of competence. This is a question from Asha on the live stream. They're asking, I want to know more about the gene editing work that you've done. So tell us a little bit more about that.
Yeah. So every living thing around you, like a plant or a mushroom or a human, is made up of DNA. And like this is like the genetic code that codes for everything. And so it got people wondering, like, if you change this genetic code, like you can change pretty much all living things. So a lot of diseases are caused by mutations in your DNA. So if you have like a duplication mutation, meaning instead of having one copy of a certain gene, you have two copies, it causes like a disease. And so if you can change these mutations, you can cure these different diseases. So that's like the premise of gene editing. And then if you so what I worked on in the Cone Lab at Sick Kids Hospital was the grand project there was muscular dystrophy in mouse models. So they managed to use CRISPR-Cas, which is a new gene editing tool, to edit out the mutation that causes Duchenne muscular dystrophy. And they saw crazy results, and it was absolutely stellar. So from there, I got more involved in gene editing, and it became clear to me that one of the first things that needs to be done is identifying which genes cause which diseases and understanding that link correctly. And in order to do that, you need really strong data sets. So you need to have a good repository of information for what mutations cause which different diseases. So I built a platform that let people add to this data set while also being anonymous, because your DNA information is very private and secure to you, and it should remain secure to you. And also still be able to get paid for your contributions, even though you were anonymous. Mm-hmm. And so I think moving forward in the future, to have really strong genetic data information, you need people from all different backgrounds to add their information to these gene editing research sets, because it's pretty, if you look at it, the majority of information that's added is from Caucasian people, typically in urbanized areas. So they go to clinical trials, and then it might cause unintended effects on people outside of the initial sample set because they weren't accounted for when the drug was first being made. Mm-hmm. So I think all those things are very important to keep in mind with gene editing. And the future of gene editing is crazy. They just had the world's first designer babies last year. You saw when they cured HIV mm-hmm. with gene editing. But I think the embryos, I don't think the babies survived in China, but I should double check that.
That's unfortunate, but you definitely double check that. But I mean, this is the question that goes outside of my circle of competence. So, so I mean, first of all, thank you for answering that. But there in the middle, I kind of got distracted. I kind of laughed. I was looking in the live chat, and there are two questions. One of them is asking for James' Instagram handle, and also someone's like, oh. When I search Ananya Chadha on Google, it's saying you're a film actor. So just to make sure that you can find the right James, the right Ananya, we'll be putting their social media in the description.
It's funny because I'm not actually a film actor. There's another Ananya Chadha who's a film actor, but it has my pictures and my website.
Really?
And my Twitter. But it has her Instagram. So it's
God. Yeah, the
you
Google.
Sure you're not a film actor?
Well, I could be.
Secret life.
Yeah, exactly.
Different personality. No, but Yeah, we'll make sure we put the right links in the description, the official verified social media handles. And yeah, all this proves that the Google Knowledge Graph really needs some fine tuning. All right, it's not perfect.
Tanmay, hop on that.
I'll be sure to contact my people. Now, I do also want to ask you a question from Akash. Well, technically, this is more of a question for me. I'll just cover this really quickly before we move on. Akash is asking, can you give us a teaser of my upcoming book on Go? Well, I'm glad you asked. So, really quickly, just briefly, the idea is this book is going to teach you about the Go language. Go language is great for concurrency and all things back-end programming. It assumes that you already have some kind of programming knowledge. I'm writing this with my friend Omer, and so it's going to be a fun book. It's going to be the second in the Tanmay Teacher series with McGraw-Hill, and there's more coming soon as well. And so that book, I will also put a link to pre-order that in the description as well. General idea is it's going to teach you how to build application backends in the Go language from scratch. It's going to teach you all kinds of things about the backend of the concurrency systems and Go routines and how they work in language runtime and compilers, and it's going to be really fun. So do stay tuned for that. All right, now a really interesting question that the two of you can answer, unless you have something to add about my Go book too, is a question from Mandar. He's asking on the live stream, how do you sustain constantly learning technology? So I assume he means things are moving really quickly. How do you sustain constantly keeping up with the latest stuff? So who wants to take the first crack at it? Go right ahead.
It's very possible to win the battle and lose the war. And it's I see this all the time where people are like, I'm gonna go ham and like learn about this, like cram it all in this week, and then I'll be like so ready and like I'll push this out and I'll know it all. But I think it's important to like do things sustainably and over the long run. So what that means is like don't like haphazardly, unhealthily force yourself to learn things if you don't enjoy it, if you're not doing it in a way that is fun for you, because then you're going to like experience burnout, or like you're not going to be able to consistently do it over a very long period of time. Mm-hmm. So I think what it means, like in order to be able to do something in the long term, and this is very key because the biggest returns in life come from compounding, like come from things like compounding over time, over a long period of time. And so how can you find a strategy for yourself that is you like look forward to, and it becomes something that you do either passively or actively that can sustain yourself for a while. That will differ, I think, for different people. But I think whenever you go about wondering how to do something, you should think about like the long term as well. So do little bits over long term rather than a lot very quickly.
I agree with that. James, what do you think?
Yeah, I think those are some good points. I think for me, it's the constant idea of having more problems to solve, right? Like you have things you want to accomplish, and so that is sort of the driving force to consistently learning, for me at least.
Mm-hmm. I also want to add something. I think it's very powerful to. Okay, there's a few things here. So first, like learn things that like make you excited and curious. Like when I speak to people about like how like the future of like brain to brain communication with brain computer interfaces, or like how might you be able to like download knowledge and skills, or like that stuff, like it gets people's curiosity going because like it's inherently like a very interesting thing to learn. Mm-hmm. Like for example, like nuclear fusion, like how might you be able to create sustainable unlimited energy forever, or like space exploration, like how can we colonize other planets? Like these questions are very cool and very interesting, and I think every field has questions like that, like if you frame it correctly to get you excited and motivated over time. So the question I think becomes like, how can you expose yourself to things that you don't even know you don't know? Mm-hmm. Because a lot of people don't even know about neurotech. They might not even know gene editing exists in the first place. Like, but these concepts are insane, but like you don't even know how to begin. And then for that, I would say like exposure is very important. It's good that you guys are like all watching this live stream, because like it seems like you guys are like putting yourself in a good place to like be exposed to things that you never would have imagined. And I think like extending beyond that, like putting yourself in situations that are like different, consuming different content on the internet, like going to different conferences, what's open up. Like I feel like those are all good strategies. Reading different books, like watching different YouTube channels.
Yeah, no, I totally agree. It's all about doing a little bit long term rather than a lot in a little bit because I've personally seen a lot of folks that I've worked with in the past that will get really, really deep into something really quickly and then just they'll realize eventually that they're really not that passionate about it and they just don't want to continue working on it. And it might just be because, they've done too much of it in too little of a time span. So, being able to stay stay consistent over a long period of time, I think, is really important. And I feel like that's something that also comes when you're passionate about something, right? Like if I'm really passionate about AI and machine learning, then I'm just going to, out of general curiosity, eventually venture into new research papers on, BERT and the unlikelihood training objective or things like this. Pretty random things that seem random, but just my curiosity sort of leads me to just do it. And so I feel like that's something that also comes as a result of passion for something. So that's definitely really interesting. Now, there is actually another question from both Akash and Tassin. They're asking, how and what should students do to actually build real-life projects rather than just sit there through programming tutorials? I think it actually goes both ways in the sense that it's important to start off with some sort of resource to get you kick-started, but it's not necessarily good to just follow that all the way through and be like, I can program now, right? It's important to then sort of take off from a certain point and start building projects to get real world experience. Like, for example, as you mentioned, James, being able to understand that whole pipeline, that whole life cycle of, ideating, figuring out how technology is going to help you solve a problem, iterating and actually solving the problem. So, but what do you think? How can students actually go about getting that real world experience?
There's a process to learning that I think is like kind of powerful and nice, which is like you first expose yourself to the topic and gain a little bit of knowledge. And then like I would like you copy tutorials that already exist. So you like replicate a project and then you replicate another project. And then like at this point, like you have like a good gist of information, you understand what exists, you understand the things you didn't even know you don't know. And then you go into building your own projects. And like that's where like most of the learning and growth comes from. So like once you've like read a few articles about AI and like maybe watched a YouTube video and like maybe like done a tutorial to build like a simple neural net, like then you can go into like, oh, I like this could be a feasible project idea, and you work backwards and go from there. So it's one of the processes they use in TKS. It's like replicate, create, and I think it has merit.
It's that's an interesting paradigm. But what do you have to say, James, as well?
Yeah, I mean, I think the idea of just following programming tutorials, it's a good way to sort of get you started, but I think it has its limitations, right? Because often if you're following a programming tutorial, you're not necessarily understanding the process of finding these challenges and maybe encountering bugs in your code that you're not sure how to go about solving, and just that whole pipeline, as I was talking about earlier, of having all these challenges along the way, but eventually achieving your goal, right? So what I would probably recommend is when you're learning these new things from these tutorials or from courses, as soon as you encounter some form of concept that or some concept that you're really interested in, something that interests you, you might want to take that and expand upon it. So that could be a new project of yours. That could be something that you work on and something that you apply in your own personal projects. And I think that's a really powerful way of learning, applying these theoretical skills that you've learned in your own unique way. And that way you get to experience all of the challenges that come along with developing some form of program. And also you get to pick up these skills and you get to sort of cement them in your brain as you pick them up from however you pick them up.
Mm-hmm.
Can I ask you a question, James? What is your process for like thinking about new projects to work on?
Sure. So I sort of have like a list of projects or like project ideas that sort of come to me at random times throughout the day. So I have it on Google Keep. So if I ever think of something, I can just pull out my phone and I can write it down. And so I'll pull it up right now and I'll see what I have written down. It comes down to like maybe if I'm like falling asleep, I think of something and I'm like, that would be really fun to build. So it could be something like generating some painting, like some landscape painting or something like that, or maybe like a carbon footprint tracker or something like adding subtitles to muted videos. It could be like from just the video feed itself. It's just like, if I'm thinking, like, I don't know, it sort of just comes to me. It doesn't come to me like quickly, but over the course of like many months, if I come up with some interesting idea of a project, I'll sort of write it down, and then I'll come back to it later.
Yeah, and just kind of forget after a while, and then, you know, like 6 months later, there'll be like a new paper from like NVIDIA that ends up implementing my exact idea, and I'm like, I could have done that 6 months ago. That's happened actually more times than you'd imagine, unfortunately, but Google keep it is. So, yeah, we're gonna keep a list from here on out. But that's thank you for sharing that. Now, there is another question really quickly from Alov. And really quickly, before I ask his question, I'm going to ask the two of you, have either of you used Flutter for mobile development? No? Okay. I have, unfortunately. And they're asking, is Flutter good for mobile development? So I'm going to take a step back here and just say one thing really quickly. For the longest time, I really have not liked this new paradigm that we're seeing of, for example, Electron apps, right? Where every app is really just an instance of a Chromium, web browser running your app on top of it. Or, for example, with mobile applications, you've got things like Flutter, which are trying to make it feel like an application is native, but not really build a native application. And look, Flutter is a step in the right direction. We used to have like Xamarin and these weird tools that were like, God no, like no one would download your app if you use that tool to build it. But now we've got things like Flutter, which are definitely the right step in the right direction, right? Like I'd still use a Flutter app, but I am a huge advocate for building native, right? We're seeing currently how the new M1 MacBooks, right? You run all the native apps on it, works perfectly. Your battery can last for literally days. You launch a single Electron app like Discord or Slack, your battery just gets eaten by Electron. So, and look, I'm not saying that it's not going to get fixed. I mean, I'm sure eventually they'll have like, platform-specific optimizations and whatever. But I would say generally build native. I know that not everyone has the resources to build native, but when you do have the resource, if you're a large company, to building an application, you don't really have an excuse to not build native. So think about your users, please, and build native. But it's good. So Flutter is not bad, but as many people will know, I like to build native with Swift. But that's just what I think about the world of technology. Any thoughts from either of you?
I think that's a good point. It sort of comes back to your our conversation earlier about, should people learn early about how to build these scalable technologies, or technologies that don't encounter these types of issues? Because there's an absolute ton of these Electron apps that are quite intensive in terms of your RAM, in terms of battery life. And it comes down to, I think, sometimes like a purposeful, like people know that and they do it, but oftentimes if it's new developers and they're building these Electron apps, often they don't know. Often they're unaware of the implications of building using an Electron app, or on a smaller scale, like some other technology that just eats a ton of battery. So it's good to know these things if you're developing an actual like commercialized product.
Yeah. I gotta say, actually, when you compile some code in Xcode, what happens is when you run it on your phone and you have your iPhone attached to your Mac, Xcode launches a debugger process so you can take a look at what your app's doing. And what Apple does is they try to give their developers some extra tools so that they don't just need to debug. They'll actually show you in a nice GUI how much CPU you're using, how much GPU you're using, and there's this one little this one little instrument that no one focuses on in the profiler, and it's the energy usage one. And even I kind of barely noticed it was there. It's one of the most important ones for your users, and yet it's the ones that developers just kind of pretend isn't there. So I feel like that's definitely something people should take a look at more. But that's just what I think. And I'm sure users would love to have better battery life as well. But regardless, there is another question from Rishika. Also, just going to quickly take this up. When can we expect another video in your deep learning series, Tanmay? Very soon, within a day or two. There will be a lot more videos coming out, so stay tuned for that. Okay, so now another question from Akash. He's saying, which career do you prefer? A development career, so for example, app development, or web development, development career. My passion, of course, is on the technical advancement side, and of course more towards that scientific element of how can we build better technology. But just being able to build raw technology isn't exciting for me, because then once you build it, it ends up going nowhere. So where I personally find most excitement, this is different for everybody. I'm sure I'm going to ask you, James and Ananya, you're going to have different opinions. Everyone in the chat's going to have different opinions. But my personal opinion is I love to work on real problems, problems that we can apply technology to solve, but that we don't necessarily have the technology to solve today. That's where my passion lies, right? For example, the analyzer project, right? We knew what the problem was. We didn't have the technology to solve it, so we were like, all right, let's start researching how to solve it. So I will also link to the Think Talk that Ananya and I did on that in the description as well, so you can watch that. But James, Ananya, where do your passions lie when it comes to development? More on the app dev or more on the scientific side?
Absolutely. I think that the idea of having two distinct groups, of having a technological job versus having a research job, it's not always as binary as that. There's a big gray in the center, which I think maybe even all three of us might even prefer to be in. I think that's probably where I lie. I really enjoy the idea of having research, like a research aspect of maybe coming up with new innovative solutions to things that have never been done before. But I also enjoy the more hands-on development side. I think depending on where you work, there are different titles for jobs like that. Like often there are like machine learning engineers, which are more hands-on on the systems, but they're also developing these new machine learning algorithms. So I think definitely somewhere in that gray area is where I see myself in the future. But yeah, I think there are definitely huge positives to each side.
Mm-hmm. And Adanya, do you have anything to share?
Personally, I think I get excited by like having a problem that like affects a lot of people, and then trying to solve the problem. So I think personally, like, since that's what makes me most excited, I'm going to spend most of my time like identifying problems that I care about and then trying to solve them in the world, and hoping that impacts people. And I don't know if that'll mean me directly programming all the time, but we'll see how it goes.
Yeah, sometimes if your passion is more on that other end of the gradient, right? Sometimes you do want to be involved with the technology because that's inherent to figuring out how to solve a problem, but not necessarily like down in the nitty gritty, actually figuring out what technologies to invent to enable that to happen, which is, what I love to do. It's sort of like, I'm not particularly binary again on either end of the spectrum, but I feel like I'm on the other end from you, where it's like I do enjoy having a problem that I'm actually working towards solving, because without that, I feel like a lot of research just goes on to archive or something and then just forgotten about for the rest of eternity.
Exactly.
But at the same time, if there's no like new exciting technology that we're building, then it's not particularly as exciting to me as it would be if there was like some brand new tech we were inventing. But again, that is completely different for everyone. So I'm sure that everyone in the chat would have different opinions as well. But here we go. There's another question from Mandar for the two of you. Have you gone through imposter syndrome?
To an extent, yeah. I think so. I think it comes back to the Dunning-Kruger effect. You have like with your level of expertise and your level of confidence, you sort of peak early and then you fall, and then you're like, there's a lot to this field that I really don't know. Because when you're up here, you're like, you don't know how much you don't know, but from the little experience you have, you're like, wow, I know so much about this field. And then you come crashing down and you realize how much more there is that you have to cover before you could consider yourself like experienced in this field. So I think I've definitely gone through periods of time where I've been at the bottom of that peak. I've been like, wow, there's so much I don't understand about this field. And I think through time, you sort of, you can definitely push through that. You can definitely, with more experience, you understand how much there is to learn and how much you do currently understand. And it's definitely a real problem though. The imposter syndrome is very much a real thing.
Yeah. What about you, Ananya?
Yeah, a lot of people go through imposter syndrome. So what you're feeling is like totally valid. I think something that is helpful to keep in mind is whenever I listen to talks of older people and like they always ask the quintessential question, um, what advice would you wish that you knew when you were getting started? Um, a lot of them end up saying like that nobody ever knows what is going on. Like nobody knows what they're supposed to be doing. Nobody knows how they're supposed to be doing it. Like everyone's just kind of like playing it by ear and trying to figure it out as time goes on. And I think that what that means is that since nobody knows what they're doing and nobody like feels like they're totally like at peace, like you should feel confidence regardless because everyone feels that way, if that makes sense.
Hmm. Yeah, no, that makes sense to me. But of course, that's I hopefully that was helpful to whoever asked that question. And I feel like one of the things to keep in mind, I mean, James, as you mentioned, sometimes it can feel like there's still so much that you don't know. But maybe what's interesting to think about is that that's relative, right? There's still a lot that you do know. There just happens to be a lot more to learn still. And there always is, right? There's never going to be a time where you know everything about a certain field, even if you're the one that invented it. So it's definitely, always going to be a learning experience for everybody. Now, really quickly, there is a note from Akash saying, please don't turn off the comments on your videos. That's automatic because YouTube detects that I'm a child and turns them off automatically. But I do turn them back on. Machine learning in action, I guess. But I do turn them back on, and I will make sure to do that for all the videos. So all of them should be on now. If there's anything, let me know, and I'll make sure they are on. But now, let's talk about blockchain. So there's a question from SS in the chat. They're asking, how much do you believe in Bitcoin, cryptocurrency, and blockchain concepts in general? Also, my webcam's kind of delayed here, but regardless, you should be able to still answer the question. How much do you believe in technologies like blockchain, Bitcoin, cryptocurrencies?
Okay, yeah. So I think there's definitely a place for them. I like cryptocurrency. It's a powerful technology with maybe a more niche application than a lot of people were initially envisioning. And I think that may have been. I'm no economist, but that may have been part of what led to the massive spike in the price of cryptocurrencies that we saw a few years ago, and obviously to the eventual crash of that. I think it's beginning to come back now, but yeah, I think there's definitely a place for cryptocurrency. It's a very powerful technology, has good security, but I think understanding the limitations of technology like that is important. Yeah.
Mm-hmm. And what about you, Nanya? I know you have more experience with blockchain than the two of us.
Yeah, the price. So there's a lot of thoughts I have about blockchain. Um, at the end of the day, I think that if anything brings you value, people will use it.
Mm-hmm.
So like if something like has merit, it will be used. So the question becomes like, do we think crypto has potential, like has value to give to the world? Um, and then if you can judge that value, like then you can like correlate it with the price of crypto if you're trying to use it for that. But I also think there's a bunch of applications of blockchain that are like unrelated from cryptocurrency directly.
Mm-hmm.
I wish I knew for certain. Like I genuinely wish I knew, but I have so many like different conflicting thoughts. The price of Bitcoin is like back up to where it was at the initial spike, which is crazy. Like I think it's at like 17,000 US dollars now again.
Wow.
And
I didn't know that.
yeah, no,
Neither
and a
did
bunch. Like if you go Google the price chart. Like you'll see like the big spike and then the crash, and then now it's like way back up, like exactly where it was at the highest point. And like a lot of firms are like saying that they endorse it. Like I think PayPal is saying that they're going to use crypto. I think the CEO of Blackstone just like congratulated crypto. I think that it's important to hedge your bets. Like you shouldn't, why not? Like I think it makes sense to have a little bit of your savings in like alternative forms of assets so that things can always be safe regardless of what happens in the world. So I think having a little bit of crypto makes sense. But at a larger scale, if I think it'll replace the fiscal system, I don't think that'll happen anytime soon.
Yeah, I agree. But remember, cryptocurrency is one of those things that people, at least at a consumer level, I think, really stereotypically associate with blockchain. But blockchain's a lot more than just that. And
Blockchain is
so,
not crypto.
yeah,
Yeah, you're right.
exactly. It just so happens that the back end for a lot of the cryptocurrencies happens to be blockchain because it's a perfect fit. But blockchain fundamentally is not, specified or only applicable in that use case. As a matter of fact, I believe that the best way to understand anything is to build it from scratch. So stay tuned for a YouTube video on that soon. All right. Can't tell you too much detail about it just yet, but all you got to know is we're going to be doing something really fun with blockchain. So that should be a fun video. All right. Now there is a question for James, and there is one more question on cybersecurity, and I believe that might be all the time that we have for today. But any more questions, feel free to put it in the chat, and I will try to take them up. The question for James is there any domain through which one can start with building programs and automate stuff? And this is from SS on YouTube.
Yeah, building programs to automate stuff. I'm going to assume you mean. Well, okay. So automation is a pretty broad term. So that can come down to automating things like maybe like automating things inside your household, like as I mentioned earlier, something to automate your like making you coffee in the morning. And if you wanted to do something like that, then yeah, you could research. You could do more research into Python, more research into robotics, like Arduino, learn how to do that. But then there's also automation in terms of like software and maybe things like your monthly finances or something like that. Maybe you want to track how much money you're spending on like groceries every month. So you hook up like some form of API to PayPal or something. I'm not sure if that's actually possible, but I've never looked into that. But something like that, where you can just input your credentials, it pulls all your transactions, and then it sorts them, and then boom, you can track how much you've done with your groceries. If you want to learn more about how to like kickstart that type of automation, then I'd still probably look into something like Python. So if you're looking for specific technologies to learn to be able to automate various parts of your life, I'd probably recommend Python. Learning Python is it's a very adaptable skill, I think. It has a lot of applications in the real world. So that's probably what I would recommend. But keep in mind that automation is a very broad field. And if you're just trying to automate everything in your life, then tons and tons of different technologies are able to help you with that. But I recommend Python to start with.
Right. And Nani, anything to add to that?
No.
Wonderful. All right. So there is really quickly another question from Gur Simran on the live stream that I do want to ask you really quickly. They're asking, is cybersecurity out of trend these days, or is it just so difficult that people prefer not to study it, or is it just simply not rewarding? So
It's out of trend?
I don't know. I feel like it is in trend.
Yeah.
As far as I could tell from a little while ago, I feel like cybersecurity. I mean, maybe I'm just not up to date or something. But as far as I know, cybersecurity is in trend, isn't it?
Yeah, I think there is definitely a sort of a shift of the type of cybersecurity that a lot of people are doing. I know within a lot of banks, you're seeing a lot more data science and a lot more machine learning being applied to cybersecurity because it's becoming more and more complex. You have it's sort of like an evolutionary war between the attackers and the defenders. You have people who are trying to break into your program with more and more advanced techniques, and then you're developing more and more advanced techniques to stop them. So it's gotten to the point where maybe the skills you want to go into cybersecurity are changing, but I don't think the field is going out of it's not going out of fashion by any means. It's definitely still in demand.
Cybersecurity will never go out of fashion. Like will never be have no demand. Like hackers will always be there. Like you will always need to like defend your cyber, like especially with more and more of everyone's lives being pushed online, like more and more of our personal data being pushed online. Like if we have like bionics or brain computer interfaces in the future, like our like biological information, like what makes us human will be online. Like cybersecurity is one of the most important things. Like and I think I don't know, but I know in my college, like a bunch of people are taking cybersecurity. My dad just took a cybersecurity class. Like I think that there's a lot of like, and rightfully so, a lot of push behind it.
Yeah, I mean it makes sense, right? I mean, as you mentioned, James, it's never, and Ananya actually, it's never, there's never going to be a point where we're like, all right, we've finished, we're finished, we've dealt with all the hackers, right? That's not how it's going to work. There's always going to be new techniques. There's always going to be something there on in terms of innovation on both ends, enabling good and bad, right? It's kind of like between the war between bacteria and phages, right? It's never going to end. There's always going to be some sort of evolution happening.
And that's why phage therapy is so important. Like,
Yes.
don't fight bacteria with antibiotics, fight it with phage therapy.
I agree. So, I mean, I feel like it's a good analogy to biology again. So that one that was good. Now, really quickly, this is a question. Not sure if this is something that you would want to answer, but okay. So let's do this. This is from Tassin. He's asking, how many programming languages do the two of you know? Which is a pretty open-ended question.
I'm not sure. Enough is what I would say.
What about you, Ananya?
Also, well, not enough because I want to know more, and I want to learn more. I would say I know Python well, a little bit of Java, but like I've done stuff with like others when required. Like I feel like if things are required, you figure it out and you work backwards, and then you like do the things that you need to do with the certain programming languages.
Yeah, I know I've had you work with like C and Swift before, and you've kind of had to just kind of go along with it. So
Yeah. I definitely have my select few that I'm most comfortable with,
Yes.
like Python, Java, C++. Those are all my sort of go-tos, but there are definitely many different excursions I've had into different areas of programming in new languages. So I'd say it's not as I couldn't put a number on that, but it's yeah.
Yeah, actually, we got a follow-up question saying, "How much is enough, James?" But really quickly before I hand that over to you,
37. 37 is enough.
precisely 37. No. So one of the reasons that this question I think is really open-ended and almost difficult to answer is because it's hard to say, you know, I know like 5 languages in their entirety, because you never really do, right? I was actually just taking a look at one of the Swift forums, and one of the senior developers in the Swift compiler community that's contributed all kinds of code just figured out some sort of basic fact of generics that most people know. And you would think that the guy building the compiler would know this sort of stuff, but he doesn't. So remember, everybody has different gaps in their knowledge in different places, and there are lots of languages that I, for example, know, but I don't specialize in, right? Like Kotlin, for example. I know enough Kotlin to get around. I'm not going to prevent myself from using it, but at the same time, I'm not going to necessarily go and write a book tomorrow about it, right? So actually, to answer Akash's question on whether or not Tanmay teaches Kotlin is the next book in the series, maybe I will keep that idea in mind. Thank you for letting me know that you want that. But that's basically it. But James, how much is enough?
Yeah, I don't know. On further thought, there's no such thing as enough. By enough, I mean I think I have enough background knowledge in certain programming languages to be able to achieve sort of the everyday goals that I have in mind. Like it comes back to that Google Keep list I was talking about.
Mm-hmm.
I have some idea of the technologies I would need to use to be able to implement something like everything on that list. So for my everyday purposes, I feel like I have some general idea of the technologies, and like I am familiar with all those technologies, but enough in the sense like I don't feel the need to learn anymore. Absolutely not. I don't think there's such thing as that, because there's tons and tons of different areas of technology that I have no experience with. So enough in that sense, absolutely not. I don't think it exists.
Yeah, I agree, right? You never really know enough languages in the sense that, all right, I'm done. I don't need to learn more. But enough in the sense that you don't feel the need to actively go learn a new one because, there's some sort of gap or something you can't build because of it. Ananya, do you want to
If
add something?
you if you can build a time machine, then you know enough programming languages.
I mean, you only really need C for that,
Or
though.
or an invisibility cloak. Oh, and James knows enough because he has the time machine beside him. It's just covered by his invisibility cloak.
Well, your secret's been revealed, James. All right, looks like we're gonna have to cut this part of the live stream and the recording now. But regardless, I mean, first of all, those were really good questions. Thank you everyone in the chat for actually sending those through. Really quickly, since we're low on time, there's one really quick question I want to ask you both. This is from Hrishka asking, who are your role models in terms of technology? Either one of you.
I think there are a lot of people I've worked with in the past that I've looked up to, and a lot of individuals who have written a lot of research that I look up to as well. Maybe some of like this past summer, for example, I would name my manager from this past summer. He's very established in what he does, and he's done some great things. So I'd say I look up to him. I look up to Ananya and Tanmay as well, two great people. And then, I guess I could just maybe a few researchers of machine learning that I've looked at before. And some computer vision researchers, Greg Morey, he's a professor at SFU. He's an influence of mine. Yeah.
That's nice to hear. What about you, Ananya?
I also definitely take traits of people that I like and kind of pull traits together to create role models of individual aspects. But I think Henry Ford is kind of cool.
Okay.
Yeah, he helped invent the internal combustion engine.
Mm-hmm.
And I last week read a book called My Life and Work by Henry Ford, and it was very good.
Very nice. I mean, I feel like what interests me about that is that's not like a sort of, I guess, almost stereotypical, like when you ask someone the question, who's your role model in the field of tech, right? I feel like that's not the first thing that would come to someone's mind. So that's really interesting. That's I'll put that book in the description as well, so if people want to check it out, they can do that too. All right, and so there are a couple more questions, but they're not particularly, on topic to this live stream. So feel free to put them in the description, and if we have any thoughts on them, in the comments, and if we have any thoughts on them, we'll go ahead and get back to you on the actual recording of this live stream on the channel. But before we actually end today, though, of course, I do want to ask the two of you one more thing, and that is that, of course, on Tech Life Skills, we've got all sorts of folks joining in. On student specials, we've got lots of students, but there's also people like developers, there's business people, all sorts of folks. So if you had to share a closing message with them, what would that message be based off of our conversation today?
I'd say try and find something you're passionate about, whether it be in tech or maybe outside of tech. Try and find something you're passionate about. Try and gain some form of meaning from that. Like it's not. You got to find something that you're interested in, something that challenges you, right? So for me, that happens to lie in certain areas of tech, namely data science and machine learning. That could be in robotics, especially. But that doesn't have to be the same for you. Everyone has their own journey, I think, inside of tech as a whole. So it's sort of a matter of finding your own path in that way, and learning things that are interesting to you. Because when you're most passionate about something, that's when you're going to be the most successful at it. Because if you're very passionate about it, you're going to spend, as Tanmay said, tons of time on it, and you're gonna learn new things. You're going to be interested in it, and it's going to be fulfilling. And that's really, I guess, the most you can hope for.
Thank you very much, James. I mean, totally agree, right? It's all about being able to figure out what it is that you're passionate about and sort of work towards pursuing that passion, because that's where you're going to be persevering. What about you, Ananya?
seeing that from a bigger picture, I think it's been super useful for me to spend some time thinking about life in general and like purpose and happiness and fulfillment and what all those things mean. And I think it holds a lot of value to look into like Maslow's hierarchy of needs, or like Aristotle talking about happiness, and like Nietzsche talking about like meaningful work. And I think if you think about those things like and you apply them to programming, then it can help you like find something that brings you a lot of joy. I think that like finding work that makes you feel like you're doing something meaningful that you enjoy, that brings you achievement, alongside people that make you feel like really good community and belonging, like is like a recipe for supreme happiness. So I think just learning about everything, questioning everything, and like you guys are stellar at this because you're watching this live stream and like actually care about learning and growth. But I think if you keep up with that, then like those are all very good things that will make you feel good amounts of purpose.
Very
Oh, I
nice.
haven't figured it out though, but I'm on the journey.
It's good to know that you're at least on that journey, right? This recipe for supreme happiness is a great way to end the video. And as a matter of fact, there are lots of different resources out there, right? Sort of expanding upon what you said. One of my favorites, I'm not sure if you've seen this, was a video from CGP Grey on 7 ways to maximize misery, which is perfectly teaching you what not to do to be happy. But I mean, first of all, I really enjoyed this discussion, right? I mean, I feel like there's so much insight that we can gain by looking at not just, especially on shows like this one, from not just looking at technology from this perspective of people who have had decades of experience, people who are like really old in the field, but also people who are still getting into the field or have already started to do great work in it. So that's why this discussion today has been really exciting for me. I've learned a lot about your opinions on the world of technology and where they sort of differ, where they sort of align with a lot of the views that I have, and I'm sure this was really helpful for everybody joining the stream today as well. So thank you very much, everyone, for joining today. And of course, thank you, Ananya and James, for joining me. One thing that I do want to say really quickly is that, of course, this series, Tech Life Skills, is held every Sunday in the morning Eastern time, so make sure you join us next week. But this week, we're also doing something a little bit different. We're actually going to have an IBM executive on the show for advertising on Wednesday. We're going to have a special episode, so make sure you join us on Wednesday as well. More details will be released later today as well. So
It's so funny and kind of, well, I don't know if this is relevant, but it's so funny that we're all children pretending to be adults right now.
I mean, yeah, I never really thought about it. I guess that's why Michael calls it Teen Time with Tanmay. kind of interesting. Good insight.
Cool.
Well, thank you very much, Ananya and James, once again. Thank you, everyone, for joining in today. I do hope you all enjoyed. Again, we will answer any other questions down in the comments below. All the links will be in the description within 24 hours once YouTube actually processes it. And thank you very much, everybody. Goodbye.
Hi. Thanks so much for having me on.
Thank you for having us. Woo.
Of course. Thanks, everyone. Bye.